Hi everybody, this is Tor Storley and I am back with another video. I thought today I will take a look at a clause that you find in Oracle called the match clause. And what I want to do is I wanted to go out and get some data from Yahoo Finance. I want to bring it in by using the tidyquant libraries in R. I will generate a CSV file out of it, and then I will import that CSV file into Oracle, and then we'll start looking at the match clause and variations of the match clause and how we can detect patterns in our data. So let's get started. So here I am in RStudio, and as you can see, I use a dark theme. And in case you wonder how to do this, you can go to Tools, Global Options, Appearance, and then you can see down here, Editor Theme, you have all these themes. As you can see here, what I did was I created this get Forex data symbols.r file. Now you could put all this together and try to use the promise package or something to await async and stuff. I tried it, I couldn't get it quite to work, so I just kind of broke it up and do it in sequences. But okay, so we got the two libraries, so let's just run those. If you already run those, you don't have to do this again. Here is the URL, and it's a web page, as you can see. So let's go and take a quick look at this web page, because this is where we're going to scrape the data from. So I'm going to open up a Google web page here, Control V and enter. And as you can see here on this Yahoo Finance page, these are Forex, meaning foreign exchange symbols that you can extract data from. And it gives you like name, last price change, percentage change. Now this is not the data you're going to extract though, but you have all these symbols, so we're going to take advantage of these symbols and see what it produces for us. All right, so how are we going to do this? Well, it's a web page, so chances are you're going to have to scrape it. And how do you scrape a web page? Well, what we can do in R is we can use certain functionality that you find in these two libraries, okay? There's a reach. I assume this comes from the RVest, but I'm not sure. If you doubt about it, what you should do is put a question mark like this, and then hit enter. And let's see, control enter, I'm sorry. And if you look here now, you can see that there are a couple of options here. Read HTML was found in the following packages. So it was found in RVest and in XML2. Now we know, because I'm using RVest, it comes from RVest. So that's where that particular one is coming from. Now where's this one coming from? Well, do the same thing. Put a question mark and hit Control Enter. And as you can see, it comes from the string R package. Now the string R package is part of the tidyverse, which loads a bunch of packages when it first starts. So that's where that particular one functionality is coming from. All right, so what I'm interested in doing then is I want to go to that website, the Yahoo Finance. I want to grab these guys. Now, how do I know what to do? Well, you can right click and you can say inspect, and it gives you all the stuff over here on the right hand side. What I'm interested in is clicking this first tab here and maybe clicking into one of these guys. For example, this one. And if you look at where that is located, now what I notice is this is a table, and it has a header and has body, and then it has TDs. It has total rows and then has TDs. But what I'm interested in is this value itself, meaning EUR USD equals X, because that's how you're going to pick up the data from this particular symbol, okay? So we have to drill in to find this stuff. So I have to possibly drill into table. I have to go in here and I got to figure out, hey, maybe this one here, in order to get to this stuff, drill in a certain way to find that out. So what I'm going to do is I have to put some ways of extracting that data. So what I can do is I can use XPath. So what that one does is looking for this, whatever's in front, and then it gets the data test, and it gets into quote link. Quote link, okay. So let's see if that makes sense. Okay, so I want to find out like where these guys are. There it says, okay, data dash test is equal to quote link. And it's an ahref type of tag, okay? So that's what I'm looking for. So the first thing I want to do is whatever's in front, get to the data test and get to the quote links. Now, when I do that, I'm going to get that element, EUR, USD, percentage signs, 3DX, question mark, P equals. All right, so maybe if I can extract this piece, I can maybe get the rest of it. So let's see what I can do. Okay, I'm looking for the href, and then I'm going to try to extract all the stuff that is equal to a P. All right. Now, this is a regular expression, and it has a little meaning. So let me try to explain this to you. What I'm looking for is what is called a backwards look. Now, what do I mean by that? Well, it's looking for something that is equal to P equals, but it's looking for something that I don't want to see the P at all. P equals. I want to find all the occurrences of it, but I don't want to see them. So as you can see, when I run it through the href here, this is what you're getting back. And it tells me that you have some kind of link, and there is a question mark, P equals. So what I'm doing is I'm looking for this particular value, and that's what I'm doing in my regular expression here. And that's what this piece is doing. It actually says, look for the one that says P equals, but don't include it, okay? I don't want to see it in the output. I only want to use it to find it. And what I'm looking for is any letter between A and Z, uppercase, that is between 3 and 6 letters. So if you look down here you get 6 letters, but here you get 3 letters, and you also have this 3DX, as you can see, percentage. And that's exactly what this regular expression is doing. So it finds all of them, and because these guys are getting into a list, I unlist it so it becomes a string, a character string of only those things. You can see it here, symbols, characters, 1 through 24, and here's the stuff. So if I run the whole thing now, instead of just stopping it short, you can see this is what I'm getting back. These are all the symbols I want to use to find my Forex data. So that's what I'm trying to do with this particular function. Now, once I got the symbols, all I really want to do is make sure I have these 2 libraries loaded, which I probably do. And I can use the tidyquant. It's a wrapper library over the quant mode library, where I can pass a vector of symbols, which you can see down here. These are all the symbols that I want to use. I'm going to get the stock prices. These are not really stock prices, but they're foreign exchange prices, so it still works. And again, I'm going to go from 2015, January 1st, through 2023, December 31st. So it's quite a long range, okay? And because I do suspect there's going to be some data that are problematic, that doesn't really have data in them, I'm going to use this drop NA function in R that will basically remove any columns that has any NA in it. So if it's open, close, high, low, whatever, if it has an NA, I will drop that row. And then I'm going to write it to a file, as you can see, a CSV file here, when I'm done. So let me run this, guys, now. In R, if you want to run all the code in one shot, you hit Control-Alt-R in Windows. Forex data, I guess that's what I called it, right there. And it has like 6 megabytes, so it's fairly large. Okay, that's fine. Let's go and open Oracle and import that data. Okay, so I'm going to import the data, and let's make sure we get the right data. It was called Forex data, not Forex. Okay, let's try that guy. Next. And we give it a name. Let's call it Forex. And we have to probably fix this particular field because it's written as date. And I think date is a key word in Oracle, so you can't really use it unless you prefix it with a quote mark. So you put it as in front and after the word to make it unique. And let's try that and see what happens. So we finished this, and it looks like it was okay. So let's go and take a look. Let's figure out how many records we got. So let's do a count. And okay, 56,026 records. So there was some more in the original data set, but because we had to get rid of those fields that had NA in them, it became a little less. So I think the original one was 86 instead of 26. So we lost some records, but that's okay. It's clean, okay? And I like that. All right, so now we get the data in Oracle, which is perfect. And now we're ready to do our analysis of the match recognize. Now, the match recognize clause is quite involved, just like the model clause is. So there's no way I can cover it all, but let me try to simplify it as best as I can. If you are looking at the documentation and you're trying to dig into it, you're going to find a lot of details about how this particular clause works. But I just want to do a high level coverage here. So when you're dealing with the pattern matching in SQL that is performed by this match recognize clause, you are looking at to recognize patterns across multiple rows of data. If you've seen my model clause video, you probably kind of see similarities here, but you will have something called partition by, and this is true for analytical functions too in any database, whether you're in SQL Server or Oracle or IBM or whatever you're in. They have very similar, because it's based on SQL standards. I don't know if it was 2011 or what it was, but you will have partition by, meaning kind of grouping by, if you will. And if you're dealing with stocks, for example, your partition by most likely will be the ticker or the symbol of the stock. And then you will order it by the rows. So in most cases, if you're dealing with stocks, it would be by date, because you want the first date to appear first and the second date and third and so forth. And then you have measures that are used to define the calculations. Now the match recognize has a whole documentations that you can check out. I'm showing you this documentation right here. Now what I did was I went into the actual documentation, which is in the data warehouse guide. I went to a specific chapter 22 and I just extracted out that portion. But if you go to data warehousing guide and you go to chapter 22, you're going to see SQL for pattern matching, and it will have anything you can dream of. And the documentation in Oracle is fantastic. They show you pictures, they show you code, talks about all kinds of variations of it, and it's really good. I love Oracle documentation. Okay, so I also loaded some stock data here. So let me show you what that looks like. And here in R, here's the code I used to kind of load some stock data. Now I only went from 2020 here in January through the end of the year of 2023, and whether there's data all the way through 31/12, no, but it will pick up whatever it can find up to that latest date. So here you can see it's pretty straightforward. You load the two libraries, you set up the tqget from tidyquant library, you put in some symbols. In this case is stock tickers, and you use the get method. Is going to be stock prices, and of course complete cases means if there's any NA problems, it will supposed to fix that by using this statement. And then I have a dplyr statement here where I pass in the data here using the new native pipe delimiter instead of the margarita symbol of percentage greater than percentage sign. So this is a native thing to R now. You can use this instead for or piping. And then I mutate by renaming this column, and then I calculate the log return here. And there's probably many ways I could have used functions within the quant mode library to do the same thing, but I just did it this way. Then I pipe that result, and I'm selecting every column but the adjusted. So there's a negative adjusted. Drop the rows that have NAs in them here, like this. And then I'm saving the data out here, calling it stock data. All right, so once that is done, I load that into Oracle. So when you see it now, I loaded that into this table called stocks that has these fields. I had to adjust, I think it was this one, and of course I had to put the quotes here for the date. Otherwise it's very similar. As you can see, here's the data. So from here now, I'm going to show you how to work with this table, and I'm also going to work with this Forex table that you can see here. And those are the two tables we're going to use for the match recognize clause. Okay, so let's take a look at, I created some snippets. In case you wonder how to do that, you can just go into view, you can say snippets, and then it pops up over here. So let me see if I can actually make that work. I'm going to close this, I'm going to go to view, I'm going to say snippets, and then it pops up over here. And what you can do is you can add your own snippets here. It's like little code chunks or queries or whatever you have, and you give it a grouping, meaning here you can see there's some examples of flashback is a grouping, OLAP is a grouping. The one that I created for this particular one, you can see there's analytical functions. The one I created for this one is called match pattern functions. So I created this category. I went in here, I said plus, and I choose a category like this. If I don't want to use any of the existing, I just create a new one here. And you can set that up once you create this stuff. And then you give it a name, and then you paste in the code you want into this snippet area here. So if I look at one of mine, for example, this one, I can say edit. And as you can see here, it pops up whatever I have available. And then I can say, okay, let's say I want the up and down V shape, right? Like this one. Click the edit button. And as you can see here, here's the name. And this is the grouping that I'm using for this one. I can type in a new group here if I want to change it and make a new one. And down here, of course, here is the code, or the query in this case, that I'm using. All right, very good. So let's now use one of these to get this started. Before I do, let's just quickly go over some of the basic definitions of some of the terms used in these match recognize. So let me just drag out one of these queries here, and then I'll talk to the definition of how this is structured. But if you look at it here, there is a clause called match recognize. Basically have a parenthesis open, and then it has a parenthesis close. And then you can give it an alias if you want to. And here you can see the alias is match recognize MR. Now you don't have to do that, but whatever you're going to refer to these columns. All right, so if you look at here, you have the match recognize clause, you have a partition by, you have an order by, you have measures, then you have some functions that relates back in to some variables you created below here, like in this define section, and you also have a pattern section. Then you have some keywords like after match, skip to, you have include all rows per match, or so only one row per match, etc. So there are certain things in here, and then there are some built-in functions, as you can see here, called match number and classifier. So let me just talk a little bit to what this match recognize is all about. So I created, so let me see if I can bring this over so you can kind of go along with me here. And I tried to minimize it a little bit here, maybe, and then drag it over so you can kind of refer over here, if you will, as we go. So let me just read through this very quickly. I don't want to spend too much time, but let me reduce it just a tad here. All right, so as you can see here, there's a summary I created here. So the pattern matching in the SQL of the Oracle match recognize clause is basically using regular expressions to match the patterns, if you will. And it recognizes patterns across multiple rows of data. So it's a row-based recognition. Now the key components, as you can see over here, is the partition by, meaning like a grouping by or logical groups, and the order by to order the rows before you start all this analysis. So that's what partition by and order by is doing, okay? Now, the measures are basically the calculations you're doing with the data you find. So as you can see, based on the pattern here and the definition of the patterns, the measures here are these guys. These are the ones I want to actually find. And you can include some custom built function that belongs to the match recognize clause also in here. So these are the measures, so the calculated outputs basically. Now you can use whatever fields you created from the original query along with what you specify in the measures here, and that could be your output. So you can include basically the original columns and the made-up columns from the match recognize clause. So the measures therefore define the calculations, whereas the pattern specifies the row pattern to match based on regular expressions. The definition here, the define statement, basically maps the rows to the pattern variables. And you also have something called like after match skip to a certain place to get started over again, meaning to restart the matching again. And that's what this after match skip to last up means, okay? So that's the basic components, if you will, of the pattern matching. Now, there are a bunch of other stuff here, and something you might be looking at as well if you have 23C, Oracle Database 23C. There's some kind of a fuzzy string match you can also perform, and you need to go into the documentation to read up on this based on this Löwenstein distance algorithm. So I wonder if it's written wrong here, Löwenstein. Yeah, okay, whatever. Anyways, so the match recognize became part of the Oracle 12C when that was released, and you can see these are the main parts, as you can see here. Okay, so I'm not going to dwell on this, but I also have a section here of how Oracle goes about solving the queries when it runs it. And without going too much detail, you should be able to find the same information that I'm using here, or you can still the video. So let me just kind of show you what I have, and then you can read it on your own. It tells you how it solves it. So you have 1, 2, 3 here, and then you have 4, 5, 6, and 7. So I'll just leave this for a second here, and you can still the video if you want to read this on your own. But basically, these are the main parts of the match recognize. So now we're going to look at some queries so we can actually execute this so you can see what this does for you. All right, this first query here is really the second one, but it's a basic up and down shape. So you can see it here. I put a description. I'll make these queries available for you if you want to try it out on your own. So the basic structure here is I'm selecting everything from the stocks table where the symbol is equal to Palantir or PLTR, and I'm grabbing a specific year and a specific month from there, just so I get a subset of data, so I don't have to deal with all the data. And then I'm setting up the partition by. I'm going to organize it by symbol. In this case, there is only one, so it's not necessarily doing anything. But then I'm going to order by the date, okay? And then my measures are going to be this date. It's going to be the down date. It's going to be the update, and then there's a couple of extra functions that Oracle makes available to this clause. And then I want to show all the records, all rows per match, and then after I match something, I want to skip to the next one, next up one. So I'm going to start at the uptick. All right, And these are the patterns. These are the regular expression patterns. It's going to be based on first start, then down. So this start is basically where it starts. It's just a beginning, if you will. It starts with the first row it finds. The down plus pattern means first down you find. If you find another down, yes, add that row. Find another down, yes, add that row. And then when you have no more downs and you start going up, include as many up rows as you can as well. And that's what this is doing, this is the pattern here. And it's based on this logic here you find in the define statement. So down is basically the adjusted close price. If that is less than the previous adjusted close price, then that is marked as a down row, okay? And this down row in text version will be included in this field, the classifier. So I will show the word. This will basically show a number. So if you have a lot of data and you find the first match in this pattern, that'll be marked 1. If you find the next group of matches, that'll be marked 2, and so on. So, and then finally I just order by symbol, match number, and date. So let's run this and see what it looks like. So down here you can see now, this is the output. And what we could do, if you think it's a little confusing, we could just remove these two fields because they really don't add to the match recognize clause. They're just used as columns, if you will, that I can use for other things. So if you look now, it's a little easier to read. You can see here, you started here on January 5th. It was 2460, and then it went down on the 6th. It went down to 2354. So that's a downtick, as you can see. This is the first match group that is getting matched by 1. Here's the second match group, and here's the third match group. Remember, we're doing a V-shape pattern here. That means we're going to start on the uptick, go down as many times as we need to, and then climb up as many times as we need to, that you find uptick data for. Once you're satisfied the last uptick here, you start over again. So this becomes the second match recognized group. Then, of course, the pattern is down first, as you can see here. The pattern is down as many times, and then up as many times. So down, down, and then it goes up, up, and then you start the third match recognized. Down, down, up, up. Start the fourth one, down, and here was just down, up. Okay, and again, you can refer to these values here to see whether it went up and down. So an uptick, it went from 2492 to 2563. So yeah, that's an adjusted close went up, and that's why it's marked as up. So that's basically the V pattern, very simple pattern, but it illustrates very nicely how this particular match recognize works. Okay, so I will move a little quicker now that you see how this works. I'll just show you a couple of quick examples. I'm not going to dwell on them. Let me get rid of this. And then you can also use aggregate functions in here. So if you look here, this one here has very similar syntax, as you can see, except I use a different ticker here and a different year and month. But I partition by, order by the same stuff. I have the same match number classifiers here. But here you can see you're using final count, running count. So here you're basically in the measures, you do a aggregation basically here. So you aggregate the data. So you do an account over all the dates to figure out the count dates. So let's run this and see how to analyze this particular query. Again, let me take out those two last columns because they don't really add much. Okay, let's run it one more time. So, okay, so here it is. So notice now, I got the match number for each group. Again, it's the same pattern. It's the V pattern again. Start, down, up. Start, down, up. Start, down, up, and so forth. First match group, you can see it here. This is the first pattern. Second pattern, here is the classifier with the word that you specified down here in your definition. You have the word, and here's your patterns. And then the number of updates, how does that work? Well, if you look at how it's computed, you can see here that the number of updates is this one. It says, take the final count of all the updates. All right, so what does that mean? Well, you got to group it first. So here's the dates, right? How many updates did you have? 1, 2, 3. That's why this one is showing 3, because it's computed by the updates. See this final count of updates. Okay, there's also a final count of dates. Okay, how many dates did I have? Well, here's 1, 2, 3, 4, 5. So 5 dates, and that's why this one is showing 5. So that aggregates all the dates on it. So you can basically add more columns to your output here. And the final one is the running count, okay? Is CNT days, which is this one. And how does that work? Well, if it's a running count, it simply adds 1 plus 1 is 2 plus 1 is 3 and so forth. So it becomes 1, 2, 3, 4, 5. Because this is the first match number, goes up through here. There's only 5 of them. Here you have 1. Here you get 6 of them, right? And therefore that says 6 and so forth. And again, it becomes what? It becomes 1, 2, 3, 4, and so on. So just individual one because it's aggregating up. Now, so that shows just slightly different variation of this one. You can also do W matching here, if you look. Here it has a slightly different pattern. It goes down and then up as many times as needed, and then it goes down again and then up. And when you run this, you can see here's the pattern, starts and it goes down, up, down, up. And then we have a head and shoulder kind of pattern, but I want to show you some of the other data too. So let's look at the Forex head and shoulder match. Now this is a very popular technical analysis indicator in many traders' arsenal. It's so-called chartists. They base on technical analysis. They read charts and they look for patterns. So if you look here, the famous head and shoulder pattern basically says you go up and then you go down. And then you go up to higher up than the previous one. And that's the head. And then you go down. And then you go up a little again, which is the second shoulder. That'd be the right shoulder, and then you go down. And then they look for like levels, like they take the bottom of each of those shoulder patterns, and that's where they draw a line, and that's like a trading signal. Whether you sell or buy, I don't know. Depends where you are, I guess. But that's what this particular pattern is doing. It's called a head and shoulder pattern. You can look it up. You just do a Google on head and shoulder pattern, and you find many examples. So you have start, up, as many times as it goes up, then down, then up to means the second up, and I want to go higher on the second up, then I go and the previous up, and then I have down, and then I get a down 2. So why do I use 2 downs and 2 ups? Well, here's the regular up, where the adjusted goes higher than the previous adjusted, but the up 2 basically says when the adjusted on the up 2 is greater than max of the up adjusted, meaning this one. Then that becomes the taller head, if you will, of over the shoulders up pattern. So that's what this particular pattern is doing. And this case, I used the Australian dollars to the US dollars. And from 2015, I found some patterns here, so that's why I'm using this. June of 2015. So let's run that. And as you can see now, the head and shoulder pattern says start, goes up, and it goes down, down, and then it goes up higher. So this pattern here should be higher than these guys, in other words. And as you can see, 7757, the 7789 is higher than this. So that makes sense. Okay, so now you have seen how the match recognize can be used to find these different patterns. There are many, many use cases. And if you look at my documentation here, you can see that some of the things that are laid out here, you can see that you can use it, for example, to find the patterns in stock prices. You can find suspicious authentication events, like in system logs, clickstream sessions you can use. How many, for example, for churn analysis, how many people sign up for your services and then drop off and so forth. So it's used for a lot of stuff like security log analysis, session analysis, financial tracking. You can use this kind of analysis. So it's very useful. Okay, the last thing I want to do then is show how I can use these results in my R code. Okay, so I took this up, flat, up, down, flat, down pattern here that I ran for the Forex. And when I run that query, you can see I'm getting this. All I have to do in my code is Control A, Control C, and I'll copy it into my R session. So here's my R session. I have these same field names as used in the query, like this. And then I just simply select whatever here and I paste it in. So it becomes this piece right here. All right. So this is the data. So in R, I'm referring to ggplot2 and dplyr, as you can see. And then I paste in, I read this into a data frame for read table, okay, like this. And then I pass in the data and I say header is true, and that creates a header for this data frame. Then what I do is I format the date, as you can see, to a specific format. And that's the date column. And then I add a new column for the trend, where I do some matching criteria. I do a case statement, basically. I say when the word is start, because up here I have all uppercase letters, as you can see. So I want to make them a little prettier. Then use the word start. If it's uppercase up, use capital U and lowercase up, so forth. So that's what this one is doing. It just changes those values, if you will, in the data frame. Down here is where I do my ggplot, pass in the data, and then you set up your aesthetics, which is your X axis. So that will be for dates. The Y axis is going to be the adjusted. So this will be the X axis of the plot, and this will be the Y axis. Then, as you can see down here, you add a line, a geom line, you add a segment, and again, I'll make this code available. I don't want to get into the details of everything in here. But what it will do is it will organize your data into a line kind of plot, but it will add labels, etc. And here you can see I'm putting down the label of the actual chart itself down here, right? But down here, I'm adding like a theme to it. And I set up the subtitles. I organize the size of them. I make it more bold and set it, whether it's centered or how it's justified horizontally. And then I add some colors to it. Okay, so if I want to run all the code again, I forgot how to do it. Run all. Alt, Control, R. Okay. And there it is. So it plots the data that I pasted in. So you can see here, I gave it a title, up, flat, down pattern for the year 2020. And here you can see in the trend is down, down flat, start, up flat. So again, the pattern was up, flat, up, and then down, down flat, down. So here you can see you start, you go up, flat, up, down, flat, and down. So that's the pattern for this one. Okay, so that's how you can see you can set up the chart in R. The last one I want to show you then is simply a head and shoulder pattern for this. All right, so as you look here in Oracle, I selected this number 7 here, head and shoulder, and here's that query for head and shoulder. And when I run it, this is what it produces. Again, Control A, Control C, go over to R, and basically paste it in right here, up through here. And that's it, and these are the columns. So now that I got this one, let me just remove this output here, get rid of it, okay? And I'm gonna run this now. So it was Control Alt R, and here you can see is the head and shoulder pattern. So it starts here, it goes up, as many ups as it can, down, down twice, and then the second up has to be taller than the first one. So that's the head of the pattern. And then it goes, well, it goes a little down, but this one is higher than the first one anyway. So it's called up 2, if you will. Then you go down, then you go up again. So this becomes the second shoulder pattern, the high point of the shoulder. And then it goes down. So you can see this is the Australian dollars. And again, all that formatting, all the centering of the plot is happening down in the ggplot section down here in the theme section. So I just wanted to show you that. I'll make this code available, and I appreciate you watching this video, and if you like it, please like it. And if you like my videos, please consider subscribing to my channel. That'd be great. I hope you have a wonderful rest of your day and the rest of the week.